Okay, here we go. Unit 4, Lesson 10, solving problems with trigonometry. So let's solve problems about right triangles. 10.1 is pretty easy. It is called What Do You Notice, What Do You Wonder? So why don't we start with this one up here. So you're just going to create a little area for you to write things you notice and things you wonder. So we'll go 1, 2, 3. Okay, notice and wonder. Alrighty. Alright, so I notice a circle on the outside. I noticed a square on the inside. I notice a radius equals 1. What do I wonder? Why are all the vertices, so why are the vertices of the square on the circle's outer edge? Why are those there? I wonder, can we draw auxiliary lines? Talk about those in a minute. What else do I wonder? What's the significance of the radius equaling 1? So that's notice and wonder for the first one. Let's do it up here for the second one. So we'll go notice and wonder. Try to get 3 each. Sometimes you really got to think about these to come up with 3 good ones. But anyway, I notice also radius of 1. So radius of the circle equals 1. Center, outer edge. I see 1, 2, 3, 4, 5, 6. I see a 6-sided polygon or hexagon. It looks like the regular hexagon. So I notice a regular hexagon. I wonder, how could we prove it's a regular hexagon? So how could we prove that it's a regular hexagon? I wonder, would there be 6 equilateral triangles we could draw? I also want to know, how does it relate? How does the hexagon relate to the square in the first figure? Notice and wonder. Okay. Here we go. Notice. Wonder. All right. So notice 1, 2, 3. Wonder, 1, 2, 3. All right, what do I notice about this one? Well, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I noticed 10 vertices. I notice again, radius of our circle equals 1. The other thing I notice is the space outside this decagon, 10-sided polygon. Just gonna color it in right there. I encourage you to do stuff like this in your workbooks just to calm you down, you know. School can be stressful, and coloring helps so much. You'd be surprised. Alright, so I noticed the area of these, the area outside of the polygons seems to be getting smaller and smaller with the number of sides. So I notice a negative correlation between the red area and the number of sides, which means as the number of sides goes up, so like from 6 to 10, it seems like the area outside the polygon goes down. All right, what do I wonder? I wonder what would a polygon with 1,000 sides start to resemble. So we've got these polygons inside of a circle. This has 10 sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I wonder what a polygon with 1,000 sides would start to resemble. What else do I wonder? I wonder I know this is 1, and I know these two are going to be the same. I wonder how we can find the area of just one triangle. And then I also want to know, how can we find the area of the red space? So all these red areas. I would wonder how we would find the area of that. Okay, so that was Notice and Wonder 10.1. This is your opportunity to get creative and really stretch your thinking. I love these problems. They offer easy opportunities to participate in class, but just check into these. Like, try your hardest and try to get creative and make it as fun as you can. Okay, cool. 10.2, growing regular polygons. We're actually going to we are going to learn about why we did this. So here we go. Here is a square inscribed. That means all of your vertices touch the outer edge of the circle, and that circle has a radius of 1 meter. Wow, they gave us the unit of measurement. Okay. What is the perimeter of the square. So we got to find the total outer area, or total outer length of this square. So, explain or show your reasoning. The first thing I notice is all the angles in a square are 90 degrees. And I also know that this side will be congruent to this side. They'll have the same length because it's a square. So those are the definitions of a square. I also know from earlier that the diagonals of a square form 90-degree angles. They're perpendicular. So say I drew a line here. I know that this is a right angle because these are diagonals, two diameters that meet at the corners. Those are diagonals of a square. Those form perpendicular angles. So 90-degree, they're perpendicular lines, so they form 90-degree angles. Okay? I know this is 1. Cool. Why? Because this is also a radius of the circle, center to the outer edge. I also know these are going to be 45. Why? Because we have an isosceles triangle, two sides that are the same, meaning the base angles are also the same. So I know a lot just by knowing my definitions of squares. So, there's a couple of things we could do here. The other way you would know this is 90 right here. Anytime you see the box, you get a 90-degree angle. Just because inside you're going to have a circle, and each of these is going to be the same. You could just do 360 divided by 4 to get 90 degrees. Because the total degrees of a circle are 360. And you now know these 4 triangles are congruent. I know that because of side, 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 side. All of them have the 1, and then the 2 annotations. So you know all these 4 triangles are congruent, meaning that all the interior central angles are going to be 90. So I know a lot just chipping away at this. But let's not get away too far away from perimeter. So perimeter is going to represent, use red for this, the sum of the lengths of the sides. So red side plus red side plus red side plus red side. Alright, so I know that the perimeter is going to be all the red sides added up together. So all I got to do is find one of the sides. And this is pretty easy. Now, you could use trigonometry. You could start labeling these opposite, adjacent, hypotenuse if you wanted. So you could go that route. So trigonometry, you could do that. I'm gonna go what I think is a little easier way. Trigonometry is definitely a good choice. But I'm gonna use Pythagorean. So the Pythagorean theorem, which as you should know by now is a squared plus b squared equals c squared. So I'm gonna go with that. Pythagorean theorem. So, what is the Pythagorean theorem? It's a squared plus b squared equals c squared. So, to find this side, I'm going to use the 1 and the 1. So we're just going to say 1 squared plus 1 squared equals, and we'll call it c squared. So c equals, we don't know yet. 1 squared is 1, plus 1 squared is 1. Meaning c squared equals 2. And then we just have to take the square root of both sides. So you're just going to get c equals square root of 2. So let's just say c equals square root of 2. All right, so we got one of the sides. Now, perimeter right here will equal a side plus a side plus a side plus a side. This is for squares. Squares perimeter will always equal a side plus a side plus a side plus a side. So you could say, because we know one of them is square root of 2, that the perimeter is square root of 2 plus square root of 2 plus square root of 2 plus square root of 2. Now let's imagine instead of square root of 2, it was, let's just do a hypothetical. So we'll call this hypothetical. Let's say it was 10. So 10 plus 10 plus 10 plus 10. That equals 40, right? Which is another way of saying, if you have 4 10s, you could say just 10 times 4, right? 1, 2, 3, 4. So 10 times 4 also equals 40. So the perimeter can be, instead of just saying square root of 2 plus square root of 2 plus square root of 2 plus square root of 2, you could just say perimeter P equals 4 times the square root of 2. So we're going to rewrite the question. What is the perimeter of the square? The perimeter of the square is 4 square root of 2, or 4 radical 2 meters. Did I explain or show my reasoning? Yeah, I did. I did Pythagorean to find c, and then I said the perimeter is side plus side plus side plus side, or in other words, 4 times s. There's your final answer. Okay. What is the perimeter of a regular pentagon? And regular means same side lengths. And a pentagon is a 5-sided polygon. Now that's inscribed in a circle with radius. So inscribed, remember that's a key word. The square is inscribed in the circle with a radius of 1 meter. Ooh. Explain or show your reasoning. Okay, that is a lot in a sentence and a question. So we gotta find the perimeter and then explain. Okay, let's just chip away at this. I'm gonna do a steps summary over here. First thing I did was I really identified the key info in the question. So the first thing you do is you identify the key info in the question, right? My second step is I'm going to actually draw a representation of the question. So I'm just going to draw a representation of the question. Okay, so I've got a pentagon inscribed in a circle with radius 1 meter. I'll probably end up just using inches. Let me just triple check. That should work right there. Okay, so we gotta start with the circle. Now they say 1 meter. I'm just gonna use an inch. That's all I have room for. I don't have room for a meter, of course. But we can definitely use our compass and build a circle. So this is gonna be our center. And I just gotta close this a tiny bit. Try not to put too big of a hole there. A little bit tighter. Okay, there we go. Okay, so we have a circle. Radius of 1. Now, I know it's a 5-sided regular polygon, which means imagine we got a circle in here. I got to get all the 5 points, so we'll call this one of them. This is a 1. I'll just use my initials, so we'll call this center F. There's an I. Okay, so I need to figure out where the other 5, or where the vertices of this pentagon are going to be. I'll show you how you can figure that out. So we drew a representation. Now what you need to do is take 360 degrees divided by the number of sides. So that'll equal 360 divided by 5. On 360 divided by 5. That equals 72 degrees. This is the magic number I need for the internal angles. So these angles right here are all going to have to be 72 if we have a regular pentagon. So I'm going to get this out and just start measuring. So the key with the protractor, line on the line, center on the center. Looks like I'm good. A line on the line, center on the center. And then you want to mark off 72, which is right. There's 71, there's 72, there's 72. Okay? Make a little point out in the distance. And there's one of your vertices right there, which we're going to call S. Now, I don't want to ruin my drawing, so I'm going to use just yellow so you can barely see it. Okay. Do it again. So again, center on the center, line on the line. That looks pretty good to me. Center, center, line, 72, right there. 72. Okay. Line up your points. Draw another line. Okay, here's another vertex, which we're gonna call H. Okay, let's do it again. So you get 5 opportunities to use a protractor, which is pretty cool. All right, center on the center, line on the line. 72, right there. Let's do another one. Vertex. Call that E. And one more. Center on the center, line on the line. Looks good to me. 72 is right on this D right here. I can barely see it. So just a little bit bigger. Alright, so there it is. Okay. Now you have all your vertices. Fisher. All right. So now we have to. So these are all 72. You got a bunch of 72. Let's do another one right here. Just so we're all aware of what's going on here. Now I've done a green circle. I've done yellow. Green Bay Packers lost to the 49ers, so why don't we use red? Because the Niners are up against the Lions this weekend. I know it's an evening game, so that means I can watch it, which is great. They're in the NFC Championship game. There's only 4 teams left. My prediction is it's going to be close because the Lions are good. Jared Goff, look out for him. He won a title when he was on the, I want to say, Eagles? The trivia knowledge is fading, but he's a good quarterback. And then in the AFC, you got Lamar Jackson from the Ravens. The Ravens look tough to beat this year against Patrick Mahomes and Travis Kelce and Andy Reid. Andy Reid's got 2 Super Bowl titles, so does Patrick Mahomes. Really excited for Andy Reid. I like that guy a lot. But go Niners, right? Let's do a little go Niners. Go Niners. All right, here's my prediction for 49ers. We'll say 49ers 24. Lions 21. That's my prediction. 49ers are going to win by 3. Okay. Now, Ravens versus Chiefs. Ooh. Got to make some predictions. I think Mahomes is going to upset the Ravens because he's so playoff tested already. Lamar Jackson's fantastic too. He's got an MVP, and he's probably having another MVP season. But I think the Chiefs are going to pull this out, and it's going to be high scoring. So I'm going to say 37 to 34. I think it's going to be close. All right, Niners are going to squeak one out against the Lions. Chiefs and Ravens are going to have a shootout, and the Chiefs are going to win at the end, like it always seems to happen. But anyway, we've got our regular pentagon inscribed in a circle with the radius 1. We figured out that the interior angles are 72. The other thing you can you can prove this. These are all radii, so these are all 1. And it's a regular pentagon, so these sides are all the same. It's pretty cool. Alright. Now, one thing we're going to do is we are going to bisect this 72-degree angle right here. And then I'm going to prove to you why it forms 90-degree angles. So if I bisect this angle, and I could do an angle bisector construction if I wanted to, but I'm not going to because it's going to take forever. But I'm going to prove to you why this line creates a 90-degree angle. Now, that line that I just drew, which is now going to be blue, is what's known as, so the blue line. I love this about geometry, is it's an auxiliary line. An auxiliary line is basically, in other words, a line you draw, a line drawn to help you. So you can do that in geometry. Now, let's assume this is 36 and this is 36. Why? Because 72 divided by 2 is 36. So you've got an angle, right? Because in the orange dashed triangle, these are both 1, you can then say, because it's an isosceles triangle, that the base angles are also congruent. Meaning you've got angle, side, angle. So these two triangles are congruent. If these two triangles are congruent, then these two angles are congruent. And because we have a straight line, one of the sides of the pentagon, the whole line would be 180. If this and this are the same, then these are right triangles. Cool. So we're almost there. You now have a right triangle, FE plus this point, and you have an angle, an acute angle that you know, and you have a side. So we are golden. We can almost solve this now. So if these two triangles are the same, then this side, 3 annotations, will be congruent to this side with 3 annotations. Meaning, if I get this side right here, I can double it to get one of the sides of the pentagon. So let's break this out. Now, I know the hypotenuse is 1. So I'm just going to try to redraw one of these triangles so we have a way to work with it. There's our 1. Okay, so we've got our right angle here. Just so I don't confuse you, I'm going to color everything the same here. Why color is so important? 36. 90. We got this other angle over here. And you know what that is already, but I'm just going to use trigonometry. So let's use the 36. This is the opposite leg, and this is the hypotenuse. So you rewrite so, ka, toa. Got the H and the O, so you're going to use so. So you will say that sin 36 degrees equals opposite, that's the O, divided by hypo. Do two things in one step. Sin 36, answer. So 0.588. So 0.588 equals op. We don't know yet. So might as well just keep it op over 1. This is where cross multiplication comes in. I realize you could probably skip a step here, but op times 1 is just op. 1 times 0.588 is 0.588. So this here is 0.588. We have 2 of them. So HE, one of the sides, will equal 2 times 0.588. That number is still sitting on my calculator, so I'm just going to say times 2. 1.176. So HE, one of the sides, is 1.176. So you now have one of the red sides. You've got one of the sides now. Every single side is 1.176. There's 5 of them, so you multiply this by 5. Still got it on the calculator, times 5, 5.878. So we'll just call it 5.9. And that represents this side, plus this side, plus this side, plus this side, plus this side. Or in other words, 1.176 times 5. That is your perimeter. And we are done. All right. What's the perimeter of a regular decagon inscribed in a circle with radius 1 meter? Let's do it again. These are fun for me. Hopefully they are for you too. All right. Still got my compass set to 1 inch, so I don't even need to change that. Still 1 inch, so we're good here. We'll just copy what we basically did on the last one. There's really only one minor difference. That is, instead of a pentagon, we have a center. We have a regular decagon. What's a decagon? That's 10 sides. Okay. So, identify the key info in the question. Radius is 1 meter. So, what's cool about this is you can do this radius to any point on the outer edge. It doesn't have to be straight up. Let's see, decagon. My middle initial is D. And I'm gonna go with my name. It has 10 letters. Let's see if there's any duplicates. J-O-H-N, no. F-I-S-H prime E-R. Okay, so we got to do an H prime. So John D. Fisher is what we're gonna have. 6 plus 4 is 10. All right. So what do we do? Well, we draw a representation of the question, but first we may have to figure out the interior angles, which will be 360 divided by 10, which equals 36 degrees. All right, so here we go. I'm gonna go fast because I don't want to lose everybody, but let me draw our center a little bigger. So center on the center, line on the line. Now we go 36. There's 35, so there's 36. There's 1 right there. Gonna use yellow for each. There's a yellow. Center on the center. Line on the line. Center, center, line, line. Right there. Shoot. Pretty sure that dot had to be right. Or was it that one? Shoot. Hang on. Center, center, line, line. 36 is that dot. Okay. So there to there. Okay. Center, center, line, line. Center, center, line, line. 36 right there. Dot to dot. Draw it. Center, center, line, line. 36. Great news about these problems is you're going to be polished with the protractor after. Center, center, line, line. Center, center, line, line. Make a little note of 36. There it was. Cool. Perfect line with the other one. That's a good sign. Not making any mistakes. Alright, center, center, line, line. Center, center, line, line. 36. Now what I'm noticing is these all straight lines. Just want to confirm that though. Dawning on a new discovery. Just want to make sure 36 is right there. What's it looks like right there, maybe? Okay. Almost there. That's straight too. Looks to be so. I think I can hypothesize that these are all straight lines. 36 right there. Yeah, it's looking like it's holding true. One more, and then we're done. Center, center, line, line. 36. There. Should be a straight line. Yep. Okay, so here we go. What do we say? J O H N F I S H prime E R. Okay, cool. Make your dots. Go red for 49ers. It's gonna be a long video. Oh well. Alright, yeah, 45 minutes. I better hurry up so it doesn't take so long to post. Ooh, I'm gonna go blue this time. My red's dying on me. Blue Decagon. Just try to get it as precise as you can. If you're a little bit off, no big deal. To draw lines, I always put the pencil down first, and then I bring the protractor straight edge to the pencil. Pencil first, bring the protractor to it. Pencil down first, bring the protractor to it. Starting to see that as the number of sides gets bigger, it starts to resemble a circle. So an infinite-sided polygon will look just a regular polygon and will look like a circle. So there you go. There's a 10-sided decagon where all these are the same. Well, these are all the same. Your interior angle is 36. So we got a bunch of 36s. So what we're going to do is we are going to draw an auxiliary line. Why don't I use this one right here. Show you again why it forms 90-degree angles. So let's chip away at this. Just highlighting the triangles that we formed. All right, now these are all one right here, right? 1 and 1. That means this angle is congruent to this angle. And we're going to assume that these are each 18. So you got 18. Because of angle, side, angle, angle, side, angle. These two are the same. Again, that's a straight line right there. So if these are the same, they have to be 90. So we have a, I'm gonna break this out down here. Hypotenuse of 1, right there. Got an 18-degree angle, so center on the center, line on the line, center on the center, line on the line. 18's gonna be right there. Wasn't a right angle, but whatever. So we got a 90. This again is 18, meaning we got to solve for opposite using hypotenuse, which is the O and the H. Our angle again is 18. So once we get the opposite, that'll be from here to here. Then we double it and then multiply it by 10. So we will say sine 18 equals op over hypo. Let's say sine 18 equals 0.309 equals, we don't know op yet, but hypo is 1. So op is just going to equal 1 times 3.309. So 0.309 equals this leg. Meaning this whole thing is 2 times that. So times 2 equals 0.618. So each one of these sides is 0.618. 0.618. 0.618, so on and so forth. And there's 10 of them. So you multiply that by 10. You're going to get a perimeter of Decagon John Fisher is 6.18 meters. This one was meters too. Almost forgot. So there we go. We are done. Throw some fun stuff in there. Do a bunch of colors. Have some fun with your drawings and your answers or whatever. Just make your life fun in geometry. Do a yellow outside of it. Trace the outline of the line I just drew. Oh, got outside the lines. Oh well, who cares? What's up, Tillman? I'm filming a video, so you're gonna be on YouTube if you talk. Yeah. Dude, what's the prediction on Niners? You'll be famous if you get it right. Not just kidding. 10 people will watch this video. All right, I'm gonna say 24-21 Niners. What about Ravens Chiefs? You got Mahomes or Lamar?
That might be a similar game.
Yeah. Give me a score prediction. Ravens Chiefs.
They might be like 17-24 that game.
24-7. Who's gonna win?
I'm gonna have to go with Mahomes.
Well, me too.
Yeah, I'm gonna have to. Until I see otherwise, I don't know.
Exactly. You gotta beat the champs.
Exactly.
Yeah. Cool, man. Good talking. All right. Hey, we're both saying Chiefs 49ers. 49ers are going to beat the Chiefs. And it's going to be 27-20. All right. It's fun to do these. Anyway, look at that. That's pretty cool, yeah? Anyways, that's out of here. Good job. Okay. Gentle descent. Here we go. Oh, what is happening to the perimeter as the number of sides increases? Went from 4 square root of 2, so 4 times square root of 2. So it went from 5.65 to 5.9 to 6.18. Interesting. So what's happening to the perimeter as the number of sides increases? It gets bigger. So that was a 4 to a 5 to a 10. Interesting. But the difference in jumping from one side was 5.9 minus 5.65, which is 0.25. And then we jumped 5 whole sides, and it only increased by 0.28. Interesting. Got to observe these things. There's some sort of math formula that we're going to get to pretty soon. All right. Coming up on an hour, so I got to hustle. Airplane travels 150 miles horizontally during a decrease of 35,000 feet vertically. So you might be like, all right, just rough draft here. Here's the most common mistake on this problem. So basically you're landing the plane, right? So most people go, all right, 150, 35,000. So as it descends, it decreases 35,000 feet for every 150 miles. But there's a slight problem. One's in feet, one's in miles. So you have to make a conversion. This is going to be the plane's path. So it's flying down to, let's just call this the airport. This is the plane currently. So it goes 150 across, 35,000 down. However, you got to get miles and feet in the same unit of measurement. Now, we could convert the miles to feet, but then you're going to have a huge number, and I'll show you how it works. 1 mile is 5280 feet. So 1 mile is 5280 feet, which means 150 miles is x times 1 is x. 150 times 5280. You'd be working with 792,000. So, why don't we just convert the feet to miles? So check this out. 1 over 5280, that's miles to feet. You can just throw the feet down here and solve for miles. So x times 5280 will equal 35,000 times 1. Divide by 5280 to both sides. That's out of here. So x will equal 35,000 divided by 5280, which equals 6.628. We want to be pretty precise on this so we don't mess it up. But we'll call it 6.63 miles. That's 35,000 feet. All right, so let's redraw it. So 6 versus 150, so it's gonna be really tiny angle. So let's just draw a straight line over here. And a little tiny one right here. Because I don't want to really mess up the drawing. I want it to be at least representative of the scenario. So let's add some fun stuff. So 150 miles horizontal. 6.63 decrease. Your plane is right here. So let's draw a plane, might as well. It's always fun. Plane coming in. So we got its wheels hanging down. Why? Because you're about to land it. Usually there's what, 2 over here? Anyway, so here's your plane. This is the plane's path. This is its current location. So you could say current location of the plane. Now, you ever heard of the word homonym? That'd be like plane, yogurt. Or maybe you're out on the plains in some pasture. We're talking about a plane though, not the plain yogurt or being out in the plains. But anyway, long story short, we got to solve for number one, the angle of descent, which is pretty easy now. And they also want us to solve for the plane's path, which we're going to call C. Why? Because it is the hypotenuse of this. That's number two. So here we go. Here's our drawing. We've got a plane. It's headed this way. It's going to land here. This is a right angle. Why? Because horizontal vertical forms a right angle. So here we go. Let's call this P. So angle P. You're gonna say 6.63 is opposite. Why? Because this side does not touch this angle. What's the 150? That's ADJ. Got the A and you got the O. That's where SOHCAHTOA comes in. SOHCAHTOA. Which one has the O and the A? TOA. So you're gonna say tangent of P equals op over ADJ, which in this case equals 6.63 divided by 150. Alright. Can't do that in your head unless you're some sort of genius. 6.63 divided by 150. 0.0442. So tangent of P equals 0.0442. Now, you use this decimal to find P. So what you're going to say is angle P equals tan negative 1, 0.0442, which equals second tan 0.0442, enter, 2.53. Don't forget what you're trying to solve for. You're trying to solve for angle P. So what is the angle of descent? You're going to say angle P equals 2.53 degrees. Box it up. There you go. How long is the plane's path? Well, that one's easy. For plane's path, we're going to use Pythagorean theorem. Good old Pythagoras gave us a bunch of cool ideas in his lifetime, and next thing you know, I'm a geometry teacher. So I love what I do because these are fun for me. If you don't love geometry, just get through the class. Like, it's okay. But anyway, if that's C, these are A and B. It could be B and A, it doesn't matter. But you just say 150 squared plus 6.63 squared equals C squared. So 150 squared equals 22,500. 22,500 plus 6.63 squared equals 43.9569. That'll equal C squared. number's still sitting on my calculator, so I'm just going to add 22500. I'll end up equaling 22543.9569. That equals c squared. Don't be scared of these numbers. Same concept. Square both sides. So you just clear that out. Second, x squared. 22543.9569. Close your parentheses. Equals c squared. Square root of c squared is c. On the calculator, it says 150.146. I'm gonna just say c. Well, you could just leave it there. That's fine. And that is in miles. So the plane's path. How long is the plane's path? The plane's path is 150. Now, you wouldn't want to just say 150 because it's a little bigger than this. You want to at least say 150.1, or you could say 0.15. That's even better. Plane's path is 150.15 miles. Now, why would this ever benefit you? Well, some of you may want to become either pilots or work in the aviation industry. Imagine you're this pilot right here. There's your plane. You've done some trigonometry, so you know that to get to Oakland Airport, you need to travel 150.15 miles. Better check your gas tank or your jet fuel tank. Do I have enough to make it 150.15 miles? You can't crash the plane because you made a mistake in math. So anyway, see how this could be relevant? Good stuff. That was lesson 10. Long video. Super fun though for me. If it's not fun for you, it's okay. Doesn't have to be, but you do have to pass the class. So I would say if you hate geometry, just watch the videos again, rewind them as many times as you need, and you have to do the practice problems, because sure, you might understand these problems that I taught you, but if you don't do the practice problems, the concepts will not stick. Now, the last thing you can do is see me at lunch, or also office hours. So my office hours are Tuesday, 4 to 5 p.m. You heard it here, 49ers. 24-21 beat the Lions. And then, what is it? 27-20, they beat the Chiefs for their 6th Super Bowl. Let's do this, Purdy and gang. I hope Debo's back. All right, anyway, goodbye. Have a good day.